For years, there's been this invisible speed limit holding AI back. Well, today, we're going to dive into Flash Attention 3, the absolute breakthrough technique that just completely shattered it. That's a pretty bold statement, right? But seriously, for the longest time, a core piece of modern AI models had this built-in bottleneck. It was like a handbrake that was always on, limiting how big, how fast, and how capable these models could really become. What was this fundamental barrier that was holding back the next generation of AI? Well, it all comes down to something called the attention mechanism. So, attention is basically the magic that lets a model understand context. How all the words in a long sentence actually relate to each other. But here's the massive catch. Its cost scales quadratically. That means as you feed a model more and more data, like a longer article, the work it has to do doesn't just grow, it explodes. And this right here is the brutal math of it all. If you want to analyze a document that's twice as long, it takes 4 times the compute power. That's 100 times the work. You can see how this problem was making it almost impossible to process really big things, like entire books or high-resolution videos. And here's the real kicker. Even the previous state-of-the-art, which was Flash Attention 2, was wasting a staggering 65% of the potential of a top-of-the-line NVIDIA H100 GPU. A huge amount of that incredible power was just being left on the table, totally unused. So how in the world did they solve this massive problem? Well, let's break down the first two absolutely brilliant techniques that Flash Attention 3 uses to claw back all of that wasted performance. Okay, so the old way of doing things, a GPU would, move some data from its main memory to its super fast on-chip memory, do a calculation, and then wait. Then it would move the next chunk. Lots of waiting around. Warp specialization completely changes the game. It creates these specialized teams of workers. One team is only responsible for moving data, while another team is only responsible for doing the math. Instead of one person running back and forth from the pantry to the stove, you have this perfectly coordinated kitchen. The sous chef is prepping the next set of ingredients, while the head chef is busy cooking the current dish. There's just no downtime. Now, the second trick is something called asynchronous pipelining. The attention calculation has a few different steps. There is a really fast number crunching part called matrix multiplication, or GEM, and that's followed by a slightly slower organizing step called softmax. What Flash Attention 3 does is just genius. It cleverly overlaps these tasks. So while a slower calculation is finishing up for one block of data, the fast matrix multiplication for the next block of data is already starting. And that's the whole point, really. This overlap effectively hides the slowness of the slower parts. The GPU's super powerful computational units are never just sitting around waiting for something to do.